Hello and welcome to Conversations in Biology. I would like to welcome my friend and colleague here at UC San Diego, Dr. Ashley Juavinett, an assistant teaching professor in the section of neurobiology at UCSD. A little bit about her background, did some digging. Grew up on the East Coast in Camden, New Jersey. She then got her bachelor's at Lafayette College, a small liberal arts college in Easton, Pennsylvania, but then got the right idea to move out west here to San Diego, where she joined the lab of Ed Callaway at the Salk Institute, where she pursued her PhD working on imaging the mouse visual cortex. From there, she went on to work on a postdoc at Cold Spring Harbor, working with Ann Churchland using ridiculously cool, minimally invasive probes to map out brain function in mice as they ran around and did normal behavioral things. And now she's my colleague, as I mentioned, as an assistant teaching professor here at UCSD. She teaches a few classes, neural data science, BIPN 162, neurobiology lab, BIPN 145, and a new class that I'm really excited about because I teach an intro class that teaches R. She does it for Python. So Intro to Python for Biologists, or Build 62. A few other things. She was in a band in grad school. I don't know. Are you still in that same band?
No, sadly, most folks have left San Diego. So,
But I highly recommend. She does an amazing cover of John Lennon's Imagine and has an adorable bunny that you can find on Instagram with the handle The Academic Bun, searching for the universe's mysteries. I'd like to welcome you. Hi, how's it going? Your students know you as Dr. J. I know you as Ashley. Welcome, and thank you for coming to talk to me.
yeah, thanks for having me. And you really did some good digging there.
Yeah, well, I'm a little envious of your website design skills. Your website is truly epic. So let's start off with the important stuff. You are a fan of craft beer and music. So I got a question for you. You're outside on a sunny day relaxing. What beer are you drinking, and what Spotify playlist do you have on?
Oh, wow. That's such a good question. I think that I don't know why, but the first thing that came to mind was there's this really good beer from Ninkasi Brewing. They're in Oregon, and they make a really great IPA. I'm sort of blanking on the name of it, but that's the beer. Um, I think the Spotify playlist, I have this playlist that I've been curating over the years that I call Groovy Chill AF. And I really, I really like that playlist. It's kind of a mix of like lo-fi and chill hip hop and even some kind of like jazzier soul. Yeah.
Nice. Oh, that sounds perfect. And yeah, I actually have a Ninkasi pint glass that I likely stole as a graduate student. I don't know. That's, I think, how we all got our glassware,
Yeah.
is pint glasses from bars. But yeah, I'm excited to talk to you about your experience as a neurobiologist and an educator. So first off, can you tell me a little bit about your journey as an undergrad or earlier and deciding to dive into a neuroscience PhD program?
Yeah, I think for me, I applied to undergrad not quite knowing exactly what I wanted to do. I was actually kind of split between neuroscience or like psychology and engineering. I knew that I really liked math and science. I knew that I was kind of like curious about how things worked, including how people worked, but I wasn't sure exactly like where that would land and what field that would land. And I actually read a book by this author, Stephen Johnson, called Mind Wide Open, when I was like in my senior year of high school. And it's all about, what at the time was cutting edge neuroscience. This is like, 2007. And kind of opened my eyes to like the fact that we didn't actually know a ton about why people did what they did, why we get addicted to drugs, why we make decisions the way we do, et cetera. And so that really, really caught my eye. And so when I went to college, I decided to be a neuroscience major. And even at that time, it wasn't super common for places to have neuroscience majors. So I think I got kind of lucky in that way. And really like what a neuroscience major meant and what it means here at UCSD is you take a mix of biology, you take maybe some classes that verge more on like psychology and cognitive science. But really you're trying to get an understanding of like what the nuts and bolts of the brain and the nervous system are. And I left college still really loving neuroscience not sure if I was like 100% wanted to do research. I had done a little bit of research during college. I had some like summer research experiences because I went to, as you said, a tiny liberal arts school. So there wasn't like a ton of research happening at the school. So I like kind of went out over the summers and did summer research experiences elsewhere. And so when I left college, I was like, okay, I like research. I could definitely imagine continuing with that, but I felt pretty open-minded. So I actually applied to like a bunch of different things. I applied to the Peace Corps. I got like an assignment to go to South Africa to teach science. And so I went through that whole process. I applied to grad schools. And then within that category, I applied to grad schools that were in neuroscience and psychology, in even a dual degree program in like public policy, because I wasn't quite sure like if I wanted to really be like just a pure scientist or like a little more broad. And so I ended up here at UCSD for a pure neuroscience program after a lot of sort of deliberation and trying to figure out like what would be best at that time. And I decided I wanted to really like see where the research thing took me and see where like getting my scientist sort of stamp as a PhD took me. And so, yeah, so I landed here as a PhD student at UCSD.
I I love how often there's this feeling in undergrad that we have to have everything figured out and have to have our whole path planned for us. And so it's great to hear that when you were deciding on programs, that question was still wide open, and it was just this big thing. I love science and want to do that. For me, it was the same thing where I knew I wanted to be outside and do biology, but
Mhm.
beyond that, research, teaching, I had no clue. But it's, hey, grad school's a good place to find out all those things. So for all the undergrads out there that are considering a graduate program for themselves, what's your advice for finding the right lab, the right environment, and earning a graduate position there?
Oh man, those are three really important and very big questions. But I think, like, to give a brief answer, I mean, I think so. The way it works in neuroscience, and this is not true of all PhD programs, is that in neuroscience, you actually get the chance to do rotations. So, and this is true in at least at UCSD, it's true for neuroscience as well as biology here. So that means, the first step is just identifying graduate programs. And so, there's a few things I would consider when you're thinking about that. You should have at least a few faculty that you're excited about working with there. You should want to live in that place because you're going to spend 5, 6 really tough years of your life in that place. And you should apply to a mix of, programs that are historically competitive and tough to get into, and programs that are, maybe a little bit easier to get into. And you can find statistics online for how many people they admit and their GPA requirements and that kind of thing. So once you've selected grad programs, you've applied, and then you get to the stage where you're trying to decide. Luckily, you get this chance to do rotations, so you can work through different labs that are there. And when you're doing that process, I would think about, how do you feel in the lab? Like, does it feel like a welcoming environment? Do you feel like you can learn there? Like, can you ask questions? Is that received really well? Do you have access to mentors that care about your well-being and your success as a scientist? And so while you're doing those rotations, you can assess things like, what happens when an experiment doesn't work in the lab? Does someone get really pissed and, go nuts? Or does someone say, look, that's science, let's figure out what happened and move on, right? So you're looking for clues like that about what kind of environment it is to work in. You might also look for clues like, what do people do when they leave the lab? Do they successfully land jobs in, academia or industry or science writing or whatever it might be? Or do people stick around for 7 years and not quite know what to do afterwards because they didn't get a chance during grad school to really explore? So those are things I would kind of tune into when you're at that stage in the process.
So when you're, in for interviews or you're meeting individuals in the lab, postdocs or graduate students, I'm sure a lot of that information isn't just kind of presented to you on a one pager. So what's that process like? Is it just having conversations with everyone in the lab, getting a sense of things?
Yeah, I think it's a tricky thing because even when you're interviewing for graduate schools, if you ask people like, are you happy in your lab? Very few people are going to be super honest with you and say, no, I'm not happy. So there's like questions I would ask, right, that are specific, like concrete things. So how often, so you're talking to another graduate student in the lab or a postdoc in the lab, you say, how often do you meet with the, main faculty, the principal investigator? Is it once a month? Is it once every 6 months? That's a red flag. Is it we meet every day and they look at every single note I take? That's also a red flag for me personally. And so you can sort of assess what feels right. For most, I think, sort of healthy mentor-mentee relationships, it looks like maybe once a week, maybe once a month, somewhere around there. So you can ask concrete questions like that. And you can ask things like I said, like what happens when something doesn't work? Like, have you had something not work in the lab? Have you made mistakes in the lab? What happened after that? Because I think one of the ways that we learn about the culture of learning in a certain place is, what happens when things go wrong.
Jumping off of that, what role do you think failure plays on the whole in the life of a scientist? Because failure, I think, typically we think of it as this hugely negative thing that we must avoid at all costs. But what has been the role of failure in your journey as a scientist?
Yeah, if you talk to any scientist, they have had experiments that have failed. And sometimes they'll know why they failed. And sometimes they'll have absolutely no idea because biology, especially, right, is just really complicated. So when I was a graduate student, I spent 1 or 2 years trying to get this particular experiment to work. And that experiment involved putting viruses, which in neuroscience we use to trace neural circuits in the brain so we can put a fluorescent thing in a virus, put it in a brain area, and then look and see where the brain area actually talks to elsewhere in the brain. And that's pretty common in neuroscience, but I was trying to do a thing where we did like a combination of viruses and we needed them to like work together and they needed to be in the right brain areas, et cetera. And so I did this for like a couple of different, in a couple of different ways for several years, and it just never quite worked the way we expected. And for me, it was one, frustrating, but two, an opportunity to kind of step back and say, like, are there other ways we can answer this experiment or answer this question? And so, like in neuroscience, we tend to be really, especially in the labs I've been in, like really excited about these like cutting edge techniques. Like, oh, we're gonna like hack together some virus that we want. It's gonna do a specific thing, or we're gonna use like a probe to record from thousands of neurons. And we're like really excited about technology, but sometimes experimental questions don't actually require the cutting edge technology that's available. So I actually kind of like took a step back and we used what are just kind of more classic tracers. And so these are, compounds that you inject into a brain area, they get trafficked through neurons and they like make things different colors so you can see what's going on. And so we were actually able to answer a subset of the questions we initially had using more sort of old fashioned techniques. And so I think for me, that was a really good lesson actually in the end, because, had things have worked with the viruses the way we had originally planned, we would have had some answers and we would have been able to see some things, but I think I wouldn't have like gained an appreciation for like the process of really distilling down what is your specific question and what exact technique is going to answer that question.
Yeah. Failure is inspiration. So then specifically kind of in neurobiology, if someone's interested in a neurobiology major or in a grad program, what skills do you think they should develop or opportunities should they seek out? And of these, is there one that's particularly surprising?
That's a good question. I mean, so the number one thing if you're applying to PhD programs is research experience. And in a normal period of human history that's not a global pandemic, that means something about like 1 to 2 years of research experience. Like I think one solid research experience with like at least 6 months in a lab is kind of a prerequisite, I think, for most PhD programs. I mentioned a global pandemic because I think that that's shifting a little bit because, as many folks know, it's been hard to get into research labs in the past year. So I suspect that might be shifting just a tiny bit. So you need like a chunk of research experience. For most programs, you need a decent GPA. But beyond that, I think there's like a few skills you might consider picking up along the way. So things like, have you been able to look at and read scientific papers and make some sense of them? Similarly, can you go to a scientific talk and maybe not understand everything that someone says, but understand enough that you could maybe do a little bit of reading afterwards and kind of fill in the blanks. And then the second thing is coding. And so, in neuroscience, especially, And this is maybe the surprising thing. In neuroscience, especially, coding is becoming pretty ubiquitous in different labs, not in all labs, and it's certainly not necessary, but it does open some doors in terms of what you can do with your data when you get into a lab, and also what you can do when you ultimately leave grad school.
Nice. What do you think specifically in neuroscience are the areas of most growth in research? Like, what big discoveries might come within the next 10 years?
Ooh, that's a really good question. I think I think neuroscience in some ways is having a little bit of an identity crisis right now in that. So I mentioned like this sort of excitement around technology and that kind of thing. And there have been tremendous and like really exciting advances in neuroscience and also in like gene sequencing, which a lot of neuroscientists do, next generation sequencing and that sort of thing. Um, and I think those are all really, really great and really important. But I think we're at this sort of like crossroads where we're like, okay, what does that buy us? And do we even have the questions that require those mega techniques and with that amount of depth and understanding? So I think that there's a couple of things that I hope will come out of the next 10 years or something. And one of them is a really clear integration of people who think about like modeling the brain and sort of thinking theoretically about how the brain might work with those that collect the huge data sets. Because without the pairing of those two groups of people, it's going to be hard to move forward as a field because you're going to have people who have huge data sets, people who think about the brain without any data, and then we won't really have a sort of unified approach to understanding the brain. Um, the second thing is I think that in terms of like medicine and in that world, I mean, there's really exciting stuff about personalized medicine and individual differences in medicine. And I think about this in terms of like how we treat different mental illnesses, how we deal with anxiety and depression and schizophrenia. And I think that we'll see this more in-depth understanding that everybody's a little bit different, and someone might have a ton of serotonin receptors and someone else might have like very few, and that really changes how they respond to an antidepressant. So I'm really excited about sort of advances in that area where the science is really going to start to directly inform how we treat really complex neurological disorders.
Thanks. Thank you. I'd like to kind of switch a little bit more to kind of the advice that you would give yourself if you could talk to kind of first year undergraduate Ashley. And so, in doing so, and I know I'd brought up kind of failure and its role in being a scientist before. I also wanted to take an opportunity to shamelessly plug your absolutely amazing book here. So you want to be a neuroscientist. This is not only the most amazingly well written and fun to read kind of compendium of all the important practical knowledge you need if you're thinking about starting a career in neuroscience, but a good chunk of the stuff in here just applies to literally any interest in biology, not neuroscience specific. And it goes from everything of what the future of the science is to how to think about your own mental health and wellness as a graduate student and beyond. So I wanted to read out a quote that you have in your section on communicating honestly. This is a quote from Santiago Ramon y Cajal. And he says, "What a wonderful stimulant it would be for the beginner if his instructor, instead of amazing and dismaying him with the sublimity of great past achievements, would reveal instead the origin of each scientific discovery, the series of errors and missteps that preceded it, information that, from a human perspective, is essential to an accurate explanation of the discovery." And for me, that resonates when I think of how we learn from textbooks, where we see this gilded final product that is a single small paragraph in a section. There's like these amazing scientists had this amazing groundbreaking discovery, and we don't hear those stories. So as an educator charged with teaching about science, what do you think are some of those important messages that you like to bring in the classroom or that you think students should hear?
Yeah, absolutely. And this is like so important to me, I think, and is like one of the most important things that we need to think about when we're training people is that we don't just show them the final product, but we show them the process. And I think in my classes that comes up in maybe two main ways. So one way, and I think you can relate to this, is like not always giving like clean data or clean examples to students, right? Because the data that we collect from any sort of biological system, whether it's like a cell or a a nervous system, whatever it is going to be messy. So data is inherently messy, and so whenever you look at a paper and it looks so clean, and you're seeing like this beautiful recording or chart or whatever it is, there's an understanding that that comes after processing and thought and decision making, not done by humans. A lot of times, even if it's done by a computer, the computer was coded by a human, about what you keep and what you leave behind, right? So first thing is like data is messy, and there needs to be like a sort of honesty about that. And the second thing is, I mean, I really try to like include where I know them anecdotes about where science has been confusing or sort of baffling, or there have been things that are not replicable. Like I talk a lot about the reproducibility crisis in my classes. And so, one of my favorite stories is the story of this scientist, Otto Loewi. Actually, like never know how quite to say his name. It's Loewi. And he, in like the 20th century, he was trying to figure out if nervous systems used only electricity or chemicals. So that, people knew that the nervous system was electric. You could like hook a lightning rod up to a frog leg and get it to move. It was pretty clearly electric, but they didn't know if there were also chemicals involved, like there was some sort of chemical signaling. And so in a really clever experiment, what he did, and he thought of this actually like in the middle of the night, he woke up in the middle of the night. It was the night before Easter. And he woke up and he was like, oh, I know exactly what experiment to do. And he was in Germany and it was really cold. And he like went to the lab and he did this experiment where he like stimulated the vagus nerve of a frog, and that slows the heart rate down. And he took the liquid out from that first frog and he took it and put it on a second frog heart. And so then the question became, okay, if we do this, does that slow the heart in the same way that stimulating the nerve would have? And as it turns out, it does. And so this really was like the first evidence that indeed there's something chemical, because we could take whatever was happening in this first heart, like suck it out, squeeze it onto the second heart and see the same thing. My favorite thing about this story, that sounds like a beautiful, clean story. My favorite thing is that people couldn't replicate this for like a really long time. And so he got this like so cool. He goes and tells all his scientist friends. He's like, I figured it out. It's chemical. Everybody's like, okay, how you do it? Well, you take the frog heart, you do the second thing. Okay, great. So they all went back to their own labs. They tried it. No one could do it. And as it turns out, it's because of the temperature. And so when he did this experiment the very first time, it was really cold. It was the middle of the night. They didn't have heat in the lab. And in those conditions, the neurotransmitter, as we now know it, hadn't like dissipated in the heart. It stuck around the terminal. And so it hadn't like moved. But everybody else was trying to do it at room temperature, whatever. And so they couldn't actually replicate it. And so it took a long time for people to figure this out, but it's a kind of great story because I think, it's like everybody was so puzzled afterwards. And it turns out it's just about the temperature of the room, which of course no one had really thought about.
Yeah, it's that pathway from going from like this fantastic, almost disaster of discovery, and then trying to turn that into something that is clean, you can replicate it. And it's that optimization process that, yeah, there's so much failure, and it takes like 80% of your time in your PhD or in your research is just getting to the starting point of collecting your data. But I don't know, as just with the curiosity we have for science, it's just, that's kind of the fun part,
Mm-hmm.
the scary part, but also the fun part.
Yeah.
So I want to step back a little bit and talk to you not as just a neuroscientist, but as a whole human. So tell me a little bit about who you are outside of neuroscience.
Yeah, good question. Who am I? Well, as you mentioned, I have a bunny, and I need to update my website because I also have a dog now. And we just made an Instagram for him yesterday. Yeah, so now my wife and I post to his Instagram, which is yeti.funfetti. I think his name is Yeti. And yeah, I mean, we so my wife and I, especially over the pandemic, like we have enjoyed now having a dog. We enjoy cooking. We enjoy being outside. We were just in Joshua Tree last weekend, so I spend a lot of time trying to just get outside, clear my mind. As you mentioned, I was in a band, and I'm not in a band anymore, but I do still play guitar, and actually these days a little bit more piano too, which has been kind of fun. And ukulele. We went to Hawaii, and I got a ukulele. So yeah, I have a lot of hobbies. Like I am very much a dilettante. Like I like to try a lot of different things, and I'm not necessarily very good at any of them. Like surfing, for example, I like surfing, but I'm pretty terrible at it. So yeah, but I'm very open minded. I like to try things. I like to try new food, new beer, whatever it might be. Yeah.
Yeah. Trying surfing, I took like a beginner's class with UCSD Rec many years ago, and I think that's just what you need to check off your San Diego membership card.
Hmm.
Is
Hmm.
that did you
Yeah.
get to do any like bouldering or climbing when you were in Joshua Tree?
When I was in grad school, I was really into climbing, and we would go to Joshua Tree pretty often and get out there. We didn't on this trip. I haven't been climbing a ton recently, but yeah, historically that has been a thing that we've done.
And so my last question is kind of the last hot ones question is
Mm.
what is up next for you? Is Dr. J the researcher, the educator, the person? What are the big important things that you're excited about that are coming up in your life?
Yeah, I mean, I guess like related to my work at UCSD, something I think a lot about these days is how do we integrate coding into our biology curriculum? And I think about this as well. So that's a really big thing. I'm writing a neural data science textbook with Bradley Wojtek, who's in CogSci, and that's really about creating a guide for people who want to learn how to do this kind of stuff on their own, want to do their own data analysis. I care a lot about the democratization of neuroscience and the ability of anybody, even if you're not like at a good school in the US or whatever, to be able to do your own research. And so that's kind of been something fun to think about too. And then personally, yeah, I mean, I think like the past few years have been like a whirlwind as an educator in terms of moving lab classes and stuff online. So I'm kind of hoping for like a chill, like, like maybe this is completely naive, but I'm kind of hoping to like maybe get back to things like, rock climbing, like guitar, in this period of like not having to spend all my weekends like figuring out what class looks like on Monday.
Yeah. Well, thank you so much for talking with me, Ashley. And for those of you out there interested in taking one of Dr. J's classes, just real quick, what classes are you teaching in the spring and in the fall? I think we're just now kind of getting our teaching set. So if a student is interested in taking one of your classes, what might they look out for?
Yeah, I teach Build 62. So that's Intro to Python for Biologists in the spring. I'm also teaching Neurobiology Lab in the spring, although both of those classes are currently full with a wait list. So it's probably a moot point. But next year, I will definitely be teaching Neurobiology Lab, at least in fall, probably winter as well. And then I think Build 62 probably in spring again next year as well. That's 2023.
Awesome. Well, thank you so much. And yeah, see you on campus.
All right. See you around. Thanks.
See ya.